Hello friends, very good morning. A hearty welcome to my YouTube channel. I am Professor M.H. Annaya. In this video, we are going to learn the isometric projection of the combination of three different solids. Let us see what is the question in store for today's video. The question reads like this: the frustum of a square pyramid with sides 50 and 40 and height 50 rests on the top of a square block. So there is a square block. On the top of that rests the frustum of a square pyramid whose dimensions are given. And above that, a hemisphere or half sphere of radius 20 is placed on the top center of the frustum of the square pyramid, which is flat surface. This hemisphere will be like this. It is resting on the top of the face with the flat surface in contact with that of the square frustum pyramid. Okay, frustum of the square pyramid. So friends, here I have written a simple sketch to give you an idea. So there is a square block of the given dimension. This is the frustum of a cone, a square pyramid, and there is a hemisphere above all. And this hemisphere's flat surface is in contact with the top surface of the frustum of a square pyramid. Friends, as usual, see, we will just take up this solid. There is a combination of three solids. We will start from the bottom block, that is a square block. That means it will have square cross section and thickness is equal to the given as see square block of side 15 thickness. So what I do, friend, I will start from this side. So I am going to write down two lines at 30 degrees to each other. And friends, from all these, I am going to write vertical lines. Vertical line from here, vertical line from here, a line from here. So three lines we have drawn. And friends, we will write these lines parallel to that now. So the height is going to be only 15 So what I will do, I will take a height of 15 here. Say 15 here. Again 15 on this line, 15 on this line. So we are going to join them by thin lines to start with, and at the end we will join them by visible lines. Friends, this is how the square block is there. Square block will have, this is the dimension what I have taken is 15, that is 50 square. A square of side, rest of the square block of 50 So this I am going to take ISO 50. What's the meaning of ISO 50? That is, whatever the length dimension they have given, that has to be multiplied by 0.815 for conversion of the actual length to isometric length. So friends, let me complete this portion also. So by drawing some vertical line through this like this. And here friends, you can draw a line parallel to this edge and another line joining here. So friends, this will become a square block at the bottom surface. And let me remove all these unwanted lines, leaving some important portion. Let me also rub this totally. Friends, now this has got a dimension of 50 millimeter. This has got a dimension 50. 50 ISO means the dimension is to be multiplied by 0.815. So thickness is equal to 15. I will simply say 15. When I say 15, it is understood. It is 15 ISO. 15 into 0.815. Friends, now let us join these two together. And now this is for the square block. And this is square frustum of a square pyramid. What dimension? It has got dimension 50 by 40 Square block of 50 So this is 50 by 40 So friends, here this is 50 again, and at the top it will be 40. What I do, I will extend all these by 50 height. So let me extend 15 height from here. 50 mm height, again 50 from this. So I extended all these by 50 millimeter. Now friends, I will form the top surface of that. So if you form the top surface, so it will be something like this. Top surface, we extend this line to meet somewhere here. This is 50, 50. And here again friends, by drawing parallel line, we are going to get this line. This line is parallel to this. Finally join that. So friends, square block we have got. The frustum has got dimension now 50 mm and 40 mm. So 50, this is 50 and the other one is going to be 40. So friends, what we do now, let me write it up. From here, 50. Yeah, the line should be parallel, then only you get a proportionate sketch friends. Friends, here, this is a square prism. For a pyramid, it has got 50 and at the top for the frustum, it is 40 mm. 50, and if you are going to leave a gap of 5 mm every side, 50 plus 10 will be 50 minus 10 will be 40. So what I do friends, I will just leave a gap of 5 millimeter from every end. So from here I am going to draw this line, a line drawn from here meets somewhere here. This is all 5 millimeter gap, 5 millimeter gap. Next from here another 5 millimeter gap. We just join friends. Here this dimension is going to be 50 minus 5 minus 5 means 40 millimeter. So friends, this is the top surface of the frustum of the square pyramid. So show like this friends. Now here friends, if I am joining this by a thin line up to here, because the base is also 50, so I will just draw a thin line here, a thin line from there, and a thin line from here. Top one, yeah, from here we are going to draw three thin line. So this is the frustum of the square pyramid, which is just above the top surface of the rectangular block. Friends, what we do, over this we have got a hemisphere which is placed with the flat surface in contact with this. So friends, that has got a dimension of how much square block? A hemisphere of radius 20. Radius 20 means diameter will be equal to 40. So this is 40. So you are going to see the bottom face of the hemisphere as an ellipse in the isometry. So friends, what I do to obtain that, I am going to make use of force center method for the construction of the ellipse. How is that? See friends, here I just take this corner, join that to the opposite side center. Say for example somewhere here, center of that. If you join like this friends, it will touch or meet the horizontal diameter here, horizontal diagonal. So taking this as the center, this distance as the radius, I am going to draw an arc here. That is center 1. Likewise friends, at the equal distance on the other end, you are going to have the second. Then this is center 3. With this as center, this distance as radius, you can have the third arc. So this is center 4, and taking this distance as the radius, we will have the fifth. So 4 centers are there. So making use of the 4 center method, we have constructed what is called the hemispheres flat. This is a flat surface. Now friends, for all the isometric projections, now we have this isometric height. The radius of that is 20 mm. So from the center of this ellipse, from here, I am going to take what is called the actual radius, that is 20 mm. I am going to draw a circle. So from this as center, radius equal to 20 actual, I am going to draw a circle. Something like this. You will get friend. Now friend, This is the isometric projection of the hemisphere which is in contact with the flat surface of the frustum of a square pyramid. Friends, now we have to see what are the lines that is left over. So friends, this is for the hemisphere, and we have got like this, friends. You can have this is for the top surface of the frustum of a square pyramid. This is one of the slant edges, second slant edge, third slant edge. We got three slant edges. Then these are all visible, friends. This is in front of you. It is visible. This is visible. And friends, these vertical lines are visible, and the bottom edges of the square block are also visible. And friends, here if you can see, we have drawn the isometric projection of the combination of a hemisphere which is on the top of a square pyramid frustum, and this is on the top of a square block having the same dimension 50 millimeter. Friends, now to make this drawing look attractive, I am going to remove all these unwanted, all these construction lines to say. So I am going to remove all these lines so that you will be able to see a better picture of the isometric projection of the combination of solids. So let me remove all these lines. And in fact, in the isometric projection, we do not even show any of this angle or any dimension. So it's going to be only a figure with three solids combined. You can have this line drawn like this, friends. And here inside this portion is not visible. So I am going to remove that part also. So this part, if you want, the construction lines can be retained. Otherwise, you can just omit them. So friends, I will just complete this figure like this. And you can see here, friends, now I think it gives you a better picture of the isometric projection. So here, this is the hemisphere. This hemisphere is in contact with the flat surface. Flat surface of the hemisphere is in contact with the top surface of the frustum of the square pyramid, and this bottom surface is in contact with the square block which is having 15 millimeter height, 50 mm. This has got a dimension of 50 at the bottom, 40 at the top. So all these lines are parallel to each other, friends. So this line is parallel to this. This measures 40, this measures 50. This also 50. Likewise, on the other side also, you have got it. And friends, remember the axis of the hemisphere, that of the frustum of the square pyramid, and also that of the square block. All these fall on the same line. That is to say, the centers of all these are collinear, or axis of this, and this, they fall on the same line. And friends, I am very sure that you would have followed the instructions or the procedure to obtain the isometric projection of the combination of three solids, wherein a frustum of a square pyramid is resting on the top of a square block, and over the surface of this top surface of the frustum, you have a hemisphere which is kept such that the hemisphere's flat surface is in contact with the top surface of the frustum of the square pyramid. Friends, please go through the complete video, and in case if you have not subscribed to my channel, which is free of cost, do subscribe it today without fail. And please, you share the information about my video and about my YouTube channel link, namely Engineering Drawing by Dr. M.H. Annaya, with all your friends. Have a blessed day. I take this opportunity to thank you all for watching my YouTube video.